A kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. A component that cannot remember anything can only ever show you the same thing. State is the memory and useState is how you ask React for it. This lesson covers why a plain variable will not do the job, how several pieces of state live side by side in one component, and what React does with your updates before it re-renders anything. There is a working counter, a form, and a batching example on the page. At the end, there is a playground with the broken version and the fixed one, 2 lines apart. State is the data a component is allowed to remember between renders. Here is the part that makes the rest of it make sense. Your component is a function, and React calls that function again every time it needs new output. Every variable declared inside it is created from scratch on that call. So a plain variable cannot survive a render, no matter what you assign to it. React keeps state somewhere else, attached to this component's position in the tree, and hands it back to you each time the function runs. That is why setting state and setting a variable are not the same operation. Setting state also tells React that this component's output is now out of date and schedules the function to run again. The counter on screen is the smallest thing that needs memory. The number is state, and the 3 buttons are the only things that change it. Look at the shape of the call underneath it. useState is given the starting value and it hands back a pair. The current value and a function that sets the next one. Both names are yours to choose. Calling that setter is the whole mechanism. It stores the new value and marks the component as needing another render. Notice that increment passes a function to the setter rather than a number. That function receives the value React has queued so far, which is the reliable way to base a new value on the old one. A component is not limited to one piece of state. Call useState again and you get another value with its own setter, independent of the first. React tells the two apart by the order the calls happen in. That is why hooks are always called at the top level of a component, never inside a condition or a loop. Keep unrelated values in separate pieces of state. Bundling them into one object means every update has to copy the rest of it forward, and you get nothing back for that work. The form here holds one piece of state, the text in the box. Every keystroke fires a change handler that sets the state to whatever the input now contains, and the box displays what state holds. That round trip is what makes it a controlled input. It is also why the line underneath can greet you on the same keystroke. 2 things on screen are reading one value, so they cannot disagree with each other. The 2 columns on screen are worth reading side by side. State belongs to the component, and the component is the only thing that can change it. Props arrive from the parent, and the component only reads them. The useful question is not which one is better. It is who owns the value. If 2 components need the same value, it stops being state in either of them. It moves up to their nearest shared parent and comes back down to both as props. That move has a name, lifting state up, and you will do it constantly. The button here toggles a single true or false value, and the message below it appears or disappears. Nothing is hiding that message with a style rule. When the value is false, the component simply does not return that element, so it is not in the output at all. That distinction matters more than it looks. A hidden element is still mounted and still holding whatever it was holding. An absent one has been thrown away, and when it comes back new. Setting state does not re-render on the spot. React queues the update and carries on with the rest of your handler. The example on screen queues 3 updates in a row, and the component renders once afterwards with all 3 applied. Read a value straight after calling its setter, and you will still see the old one because the variables belonging to the current render never change. From React 18 onwards, this batching applies everywhere, not only inside event handlers. Updates from a timeout, a promise callback, or a native event are batched the same way. The lesson you're watching runs React 19.2. The reason for any of it is plain enough. 3 renders where one will do is 3 times the work for the same picture. useState adds one piece of memory to a function component and returns the current value with a setter. Calling that setter is what schedules the re-render. Assigning to the variable does nothing at all. One component can hold as many pieces of state as it needs as long as the hooks are called in the same order on every render. State is private to the component that owns it, and props come from the parent and are read only. One correction to the wording on screen. State is not mutable. You never edit a piece of state in place. You hand React a new value and it replaces the old one on the next render. This first version is the mistake that is worth making once deliberately. The component keeps its count in a plain variable declared inside the function, starting at 0. The increment function adds 1 to it and logs the result. Click the plus button and the console really does count up, so the code runs and the arithmetic is right. The heading never moves. Two things are going wrong at the same time. Nothing has told React that anything changed, so it never calls the component again. And if something did call it, the function would run from the top and create that variable at 0 all over again. The note in the middle of the screen says exactly that. The variable updates, the interface does not. The reset button at the bottom has the same problem in a shorter form. It assigns 0 to a variable that nobody will ever read again. The working version opens with the import because useState comes from React. Then two calls, one for the count and one for the name, each returning its value and its setter. The counter markup is unchanged from the first version. Same heading, same buttons. It updates now purely because those buttons call a setter instead of assigning to a variable. Plus and minus both pass a function, so each one works from the value React has already queued. Reset passes a plain 0, which is fine when the new value does not depend on the old one. Below the counter is the second piece of state. The input is controlled. Its value comes from state, and its change handler writes every keystroke back. The last line renders the greeting only when the name is not empty, which is the conditional rendering from earlier in a single line. Two independent pieces of state in one component, and neither one knows the other exists. The model to keep is short. A component is a function that React can call again whenever it likes. Anything that has to survive that call must be held by React, not by the function. useState is how you ask for that, and the setter is how you tell React the value has changed and the output is stale. Everything else in this lesson follows from those two sentences. The next time you assign to a variable inside a component and wonder why the screen will not update, that is the question to ask. Who is holding this value? The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.